Hi everybody, welcome back. So today I wanted to show a couple of things. I wanted to start with a cool update from Jay. He implemented a feature that lets you implement cascading drop-down lists in Elsa 2 without make changes to the front end. And to show that off, there is a small example in the Elsa sample server host application, which has a dynamic vehicle activity. So first I will show what it looks like from the designer's perspective, and then we'll dig in a little bit into this activity to check out what it takes. So let me start the server and the designer. All right, so I'm creating a new workflow, and then I will look for the dynamic vehicle activity, which is a custom activity. And as you can see, this custom activity has three properties: brand, model, color, and they are configured to display a dropdown with a set of values that are available to you to choose from. But these are cascading, and what that means is that the items available from this dropdown list depends on the value selected from the first one, and the same goes for the color dropdown list. Its values depends on the values selected in the model dropdown list. So for example, if we change this to Peugeot, then we saw the list change to a different set of values, and then depending on the selected model in this example, the set of colors changes as well. These are cascading drop-down lists. All right, so what does it take to implement this? So for that, let's take a look at the activity implementation. So here we are. I'll zoom in a little bit. So first we declare the brand property, and as you can see, it uses a UI hint of drop-down. The second one uses a drop-down as well. This is the model property and the color. And to provide the available set of options, you configure each property with an options provider, and the options provider needs to be a type of a class that implements the iActivity property options provider. In this example, the dynamic vehicle activity class itself implements this interface, but this is not required. It could also be a different class if you want to. So let's take a look at the implementation of this interface of this class. So this interface exposes a method called getOptions. So we'll look for the getOptions method here. And here what this does, it returns an object called runtime select list provider settings, which expects a couple of values, a provider type, which is the current type, and an optional context. But for cascading, you need to return the cascading dropdown context. So the depends on events is a setting on the activity input, and that's where you declare the dependency properties. So in this case, this means whenever the value of the brand property changes, it means that this dropdown list needs to be refreshed. Yeah, and so in the case of the color, it depends on values changed in the model property, but it depends on the values of both model and brand. So probably this will set up a event listener that reacts to changes made to the model and the brand list. So that's what you configure here. This is for demonstration purposes, which we'll ignore. Yeah, so that's to get the options. And then another interface to implement is the iRuntime select list provider, which exposes the get select list async method. And this will be invoked from the designer through an API endpoint into this function. And here you will receive the cascading dropdown context. And from this context, you will get the name of the dropdown list for which you need to provide values. So here I just set up a dummy data source, but you can of course get data from the database directly. And just to show you the get data source implementation, it returns a array containing brands. So this is one brand, this is a second brand, and each brand has a set of models, and each model has a set of colors. So this is a dummy data source. And then depending on the value being requested, I select the brands from the data source. If a set of models are selected, then I first need to know what's the current brand, and the current brand is provided through the dependency values object. That's a dictionary that's provided through this context here. So it's a little bit to dig through, but the nice thing about this is the only place where you need to configure cascading dropdowns is from this activity. Or, as I mentioned, you can implement this in a separate class. But you don't have to make any changes to the front end to make this work. All right, next up, I've been working on the Elsa 3 designer. Last week, I showed some progress on the ability to embed activities within another activity. This has been refined some more, so we will look through that, and then we'll also take a look at the workflow journal progress. So let's switch to Elsa 3. The server is running and the designer project is running as well. So here it is. This is the dashboard. So first, let's take a look at the flowchart demo. I think this is basically what this lets me show you is the ability to actually add flowchart activities to the designer and being able to edit its contents. So what we have here, there's a simple right line activity. Then there's a flowchart activity. And if we click the pencil button, we enter its designer. So as you can see, we went from flowchart 1, which by the way is the root activity. So this is the first activity to execute from the workflow definition, and then the second flowchart. This flowchart activity is its own little workflow, if you will. So it starts with another right line activity that writes the text hello world, then a triple dot, which itself, this activity is also a flowchart, so we can drill into that one. And the only thing this thing does is iterate over a set of items, and in this case it's looping over an array of 3 dots. So just to mimic some progress. And then the body looks like this. So it waits for 1 second and then prints the current item, which of course is a dot. Okay, so let's go back up. So now we are here. So we are printing hello world. Then every so many milliseconds, I think 3/4 of a second, we'll print a period. And then final right line activity from this flowchart. Then we go up 1 level, we write the end right line. All right, so let's publish this workflow and then we will give it a run and see if it works. So while that executes, I'm switching back to the console, and indeed we see the start right line activity. Then we enter the flowchart activity, which writes hello world. Every second or every 750 milliseconds, it writes the current item in the list, then another right line, and then in the root layer, the final right line. So this ability to group activities is very powerful because it lets you create a maintainable workflow where you can group functionality together in higher level activities like this. But the next step, of course, will be the ability to visually define custom activities from the designer. So basically being able to create your own activity library from the designer without having to write them in source code. Of course you can. These workflows being created through the designer can also be created in code, including custom and composite activities. Being able to do it from the designer should be very productive. The first category of those custom activities will be activities you define using the designer, similar to being able to do it like this, where you create a bunch of activities and connect them together. But it will also let you configure input and output variables so that you can create custom activities that receive a bunch of input properties and return one or more output. And the mechanism will be variables. Right now there's no type of variable. Of course there's a data type, but there will be a direction, if you will, an in direction and an out direction, which is very similar to Windows Workflow Foundation 4. These variables are linked to the workflow definition itself, but container activities such as the flowchart type, they can have their own scope of variables as well. So that will be leveraged. The second category of custom activities will be templated activities. So imagine you have different kinds of HTTP endpoints. Maybe they listen for certain webhook events. You want to use them across workflows. What you could do is create a new activity, configure its values using for example, here you can configure supported methods, policy, and a path. Although HTTP endpoint is not a good example because typically you will only want one kind of endpoint. So let me find another example. Well, to be honest, the set of activities here is a little bit limited. Maybe it will be a run JavaScript activity, right? So you want to execute a bit of logic, but instead of having to copy and paste this script in all of the activities where you want to use it across workflows, you would just create one templated run JavaScript activity with the specific code you want to execute. And then that template becomes available as a different activity. For example, it would be execute my custom logic activity right underneath scripting, or another category that you can specify. So that's the second category of custom activities that you will be able to implement. And the third category will be scripted activities. So what it will allow you to do is you will manage a set of scripts. So these are not activities, they're just script definitions, and they could be of any language that the system supports. So initially it will be just JavaScript, but it could also contain Python, C# even, and anything else. This system will be extensible. And the nice thing about this will be that users will now be able to implement activity logic from the designer. These definitions, these scripted definitions, will become available as activities. And I'm thinking of maybe implementing Node.js so that you can use JavaScript and write activities the same way you can do it in C# directly, where you have access to all of the services and the runtime, etc. But instead of doing it from C# source code, where you have to compile everything, you can do it straight from the designer and it will be evaluated at runtime. This is just an idea. It's going to be experimental, but we will see how far we get with that. All right, so let me clean this up. So the final topic is the workflow journal. And the workflow journal is a list of steps that a workflow went through as it executed. So for that, we will look at the workflow instances, and we'll take the last one that I just ran. And the idea of the workflow instance here is that it shows you the workflow definition at the time it executed. So it's bound to the version of the workflow definition when it executed. It doesn't have navigational support yet, the same way it does with the workflow definition editor, but that's coming. We'll close this. We'll open it. Here it is. So what we see on the left-hand side is the journal. And the way it works, it starts from the root. So every workflow definition starts with a single activity. And when created using the designer, that will always be a flowchart for now. And the flowchart contains, as you can see, 3 activities. The start activity, the print hello world activity, this one, and the end activity. So that's what we see here. So first it executed the flowchart. And as part of that flowchart, it executed start, print hello world, and end. And of course, the print hello world itself is also a flowchart. So we can drill into this one. I don't think this actually works, surprisingly enough. But yeah, so drilling into that one, we see that hello world executed, the ... activity, which itself is also a flowchart, and then the goodbye cruel world write line activity executed here. And we can drill into this one as well. And indeed, it executed the for each. And you can see the 3 iterations of the for each. So if we go into this one, we should be able to expand this one and see that both wait 1 second executed for about almost a second. So this makes sense because it was configured to 3/4 of a second. So it's not very accurate, at least the recording of the execution time. I don't want to say quarters isn't accurate, maybe it is, but there may be some lag time between when it executed and the event got logged and persisted in the database. And then of course the print current item executed as well. And then the second iteration and the third one. So this is what the workflow journal looks like right now. It's an initial version. We might enhance it, maybe make it more visual, that we are in a nested level of the hierarchy. Right now it could be confusing. I think that everything is at the same level and yet it's nested, but yeah, we'll give it some thought. All right, so I briefly mentioned what will be next, and that's the ability to create custom activities from the designer. Another feature that I'm planning on working on is flow node activities. So let me show you why we need it. Let me just create a new workflow to show that. So let's say we have a write line activity and an if activity and another write line. So as you can see, the if activity has a then and an else port, as it's called right now. These are properties on the if activity, and they are of type I activity. So we can add one activity or assign one activity to the then property. And through the designer, this will also be a flowchart for now. I am planning on adding support for the ability to drag and drop an individual activity straight into one of these ports so that it doesn't have to be a flowchart. And maybe also being able to do it straight from the designer into it. But we'll see. Maybe that comes later. But what I want to talk about is the fact that the then and else ports, they are enclosed within the if. So there's no way to right now to have logic in the current view from where you can connect another activity to the then and staying in the same level in the same flowchart. And for that we need a different kind of activity, and I call that the flow node flow activities. And what it allows you to do is to have a similar activity that we have in Elsa 2, where we have 2 outcomes, a true and a false outcome. So it's conceptually a little bit different. It will still have a condition to configure, but instead of the activity scheduling the then or the else activity, it will communicate to the flowchart activity that the true or the false outcome has yielded. And that will then cause the flowchart activity to schedule the next outcome or the next activity connected to the true or the false outcome. You'll have that kind of activity. Similarly, we'll have a version of the switch activity, which right now behaves similar to if, where you have embedded activities, but the flow switch activity will have outcomes like these little ports here from which you can connect other activities in a flowchart style. So yeah, I'm pretty excited about that. Overall, it's coming along nicely. There's a little bit of work to do on the runtime itself, just some optimizations and implementing a runtime that does not rely on the proto-actor framework, although the proto-actor framework is great when you are hosting in a multi-node environment. But I also would like to offer a runtime that's simpler, but maybe more suitable in single node environments. Maybe if you implement a workflow service just to do some tasks, maybe you don't need an actor framework. All right, that's all I had. I'll see you next week.